Hello, 7th graders, it's Mrs. Tremblay. It is now time to learn how to divide integers, the last operation. So exciting. You can actually use the fact that multiplication and division are inverses to help you understand the rules for dividing integers. So just like those addition rules helped us with subtraction, your multiplication rules are going to help you with division. I remember looking at the textbook that is used in elementary. I was on that little committee where we chose it. You had to do some things with fact families, right? So you learned the addition and subtraction families and the multiplication and division families. For example, in the problem 4 times 3 is 12, we could write this as two division problems. 4 times 3 is 12 means that 12 divided by 3 is 4, or 12 divided by 4 is 3. So it's basically that idea of working backwards using opposite operations. So if you understand the positive version of this, which I know you do, we're going to use that with some negatives to help us, again, discover the rules, because discovering is so much more fun than me just telling you. Some of you agree with that. I know some of you disagree, but just bear with me. It'll be okay. Okay, so I have negative 6 times negative 3 is 18. We know this is true. We just learned that when you multiply two of the same sign, it's positive, and 6 times 3 is 18. I could also rewrite this, and we're going to rewrite the the two division problems this would represent. So if 4 times 3 is 12, not changing the digits, we said 12 divided by 3 is 4, right? So this would mean that 18 divided by negative 3 would be negative 6, according to this up here. This also means that 12 divided by 4 is 3. So that means that 18 divided by negative 6 would be negative 3. So we changed nothing about the digits, we just rewrote this. The same would be true for this next one. So in this one I was multiplying the two negatives. With this next example here, a negative 6 times 3 is negative 18. We know that's true. When you have unlike signs, it's negative, and 6 times 3 is 18. So the two division problems, I keep doing that, would mean negative 18 divided by 3 would give you negative 6, and also that negative 18 divided by negative 6 would give you positive 3. So we didn't change any digits again. All right, the last one, all kind of similar to one another. We know that 6 times negative 3 is negative 18, because it doesn't matter which one's greater. If you are multiplying and you have one of each, it's a negative. So this is true. That means that negative 18 divided by negative 3 would equal a positive 6. And a negative 18 divided by a positive 6 would give you a negative 3. So these are all of our families, right? Now just like before, we used patterns to help us with the multiplication rules. We're going to use that with division. Quotient is the result of a division problem, right? So in looking at all of these little solutions you have here, the first thing I want you to notice is that 18 divided by 3 is still 6, and 18 divided by 6 is still 3. So in order to get the digit, you're dividing normally in all of these, right? Regardless of the sign, you're dividing normally. Just like with multiplication, you multiply normally. The difference here is what happens when you have two integers with the same sign and what happens when you have two integers with different signs. So let's look first at when you have two integers that you're dividing with the same sign. Those are different, those are different. Here's one. I'm dividing two negatives and I get a positive. And here's another one. I'm dividing two negatives and I get a positive. That sounds very similar to multiplication, doesn't it? With multiplication, when you have two integers with the same sign that you multiply, you always get a positive answer, right? Good news. The same thing happens with division. When you divide two integers with the same sign, your result is always going to be positive. So the quotient of two integers with the same sign is positive. Now take a look at when you have two different signs. That's the next one. So here I have two different signs and I get a negative. And I know it's not the same as addition because 18 is greater than 3 and 18 is positive. Here I have one of each. The answer is negative. One of each, the answer is negative. One of each, the answer is negative. So again, these rules are the exact same as multiplication. The quotient of two integers with different signs is negative. So same sign positive, different signs negative, dividing exactly the same. So this means that the rules for multiplication and division are the same. And I would put a little smiley face because that means I only have one operation to memorize and the other one is exactly the same as that. So this is great news, right? Now what I'd like you to do is a little bit of practice. It says, let's practice. Find each quotient. So again, quotient just means what's the result of the division problem. Now is the time where I would like you to pause me and try these on your own. Just a reminder, the way you divide is the same. Divide the digits normally. If you see two of the same sign, it's positive. Two different signs, it's negative. So press pause. Welcome back. Okay, first off, 40 divided by 8 is 5, because I know that 5 times 8 is 40. And two of the same sign means it's a positive 5. Done. All right, next I have 0 divided by negative 6. Anytime you're taking 0 divided by something, it's always 0. And 0 can't be positive or negative, so leave it alone. All right, next, this is written as a fraction. Remember that this little fraction line means division. So this means negative 49 divided by 7. So 49 divided by 7 is 7, and a negative divided by a positive is a negative. Next, again, this means 21 divided by negative 3. 21 divided by 3 is 7. And when you have a positive divided by a negative, doesn't matter which one's greater, one of each means it's negative. Almost there. A negative divided by a negative. So 28 divided by 7, that's 4. A negative divided by a negative is a positive. This last one is a little bit different than all the rest that you've seen. This is one of those little tiny things that can make a big, big difference in your answer. So I didn't put this negative with the 15 or with the 5, did I? When you see the negative sign in the middle, it means, kind of like when you look at the opposite of, but it means take 15 divided by 5 and your answer is negative. So what's 15 divided by 5? It's 3. And the opposite of 3 is a negative 3. This doesn't mean that 15 is negative and 5 is negative. Okay? And in order to understand this, think about this. If I gave you the number negative 2, to write a whole number as a fraction, don't you just put a 1 underneath it? Right? So negative 2 would have the same value as negative 2 over 1. Correct? Does that mean that this 1 is also negative? It doesn't, because if you had a negative divided by another negative, isn't this negative 2 all of a sudden a positive 2? So if you see that negative sign right in the middle, it means that either the 2 is negative or the 1 is negative. In either case, a negative 2 divided by 1 would give me a negative 2. A positive 2 divided by a negative 1 would give me a negative 2 also. So that's another way to look at it. If you see the negative sign right in the middle, it means that either the numerator is negative or the denominator is negative. It doesn't mean that both of them are. I think it's much easier just to look at this as, okay, the opposite of the result of that. So find that and take the opposite of it at the end. So many different ways to look at it. I think we'll explore that and talk about it more in class tomorrow. I'll see you then.